All right, so here in chapter 3, we're going to be talking about inductive reasoning. And we talked about deductive reasoning back in chapter 2, although we did cover some inductive reasoning just to show the differences between them. And where deductive reasoning is about going from theory down to specific examples, inductive reasoning is when we will move from specific examples up to making generalizations about the information that we have. So we'll be talking a lot about the limits of generalizing and the problems that come with generalizing. All right, so some of the things we're going to do in this lecture are identify the strengths and weaknesses of different kinds of evidence used in inductive arguments. We're going to distinguish between good and poor inductive conclusion, because we can make conclusions, but they can be good or bad. Recognize the limits of inductive reasoning, and then we'll recognize the errors associated with inductive reasoning and informal reasoning. You will recognize a lot of these. So we'll start out with just a quick what do you think, and this will be kind of rhetorical, just something for you to think about. So what do you think? Lee Freed, a student, told Duke's president that he predicted an important event that would happen in the upcoming week and put it in a sealed envelope. Okay, sounds like a fun thing. The envelope was not to be opened until the end of the week. The note inside described the jumbo jet crash that would kill hundreds of people, which is an unlikely event that had actually occurred that week. So, can people who claim to have precognition accurately predict the future? If you look at that example and if you read through it in the book, you might be led to believe that they can. Another part of what do you think is, can instruction improve students' critical thinking, and how do you know? Okay, so can you know that somebody has better critical thinking because there's been instruction? Does subliminal learning work? So these things that happened underneath the limit of consciousness, so subliminal, can they work? So can you play recordings for learning a foreign language while you're asleep to help you learn that language? Okay. And then last, how much should you trust your personal experience in drawing a conclusion? So these are some things to think about as we go through this to keep in mind, and we'll answer some of these questions in various levels of detail, but we are going to address some of the more important aspects of Chapter 3 and talk about inductive reasoning. So inductive reasoning is about generalization. We're going from a small amount of evidence and trying to draw a larger conclusion based on that. Okay? So if you jump in a pool at a water park and that water is cold, you might suspect that the rest of the water in the rest of the water park is cold too. Okay? And that might be an appropriate conclusion to draw, but it might be vague in general because maybe other pools are heated, or maybe the water slides are heated, or whatever it is, or maybe the kids' pool has more pee in it and it's warmer because of that. That's gross, and I hope that's not the case. But it's possible, I guess. I don't know. It's kind of weird, but that's okay. Keeps you on your toes, right? So could we draw a conclusion about the rest of the water based on the observations that we make? Well, then you start thinking to yourself, well, don't I have to get more information to make that conclusion? Yes, that would be helpful. Do you have to have all the information to draw a conclusion? Well, not unless you want to have a conclusion that is that's cogent, meaning that it has all the possible aspects considered. But generally, getting a large enough sample will be good enough. We'll get into that a little bit later. Okay. Usually what happens is that people will generalize from their personal experiences. I have worked with people who have different levels of psychoses in my private practice as a psychotherapist, and a lot of times people will believe that they predicted the lottery even though they didn't play it. Imagine that. I keep telling them to play it and they never do. But people will make a conclusion about their personal experience, or I had a dream that came true. So that means that dreams are things that predict the future. So you have kind of a precognition. Okay, so that's another kind of inductive reasoning that has various levels of validity to it. Another example, people use induction to predict events. Like, it will probably rain today because it has all week. Okay, so now we're starting to think about the past predicting the future and if there are likelihoods, and then we talk about what are called independence of observations. Is something going to happen just because something has preceded it? Okay, so these are all types of inductive reasoning that have various levels of validity. And as we go through this chapter, we'll talk a little bit more about what's a more valid way to use inductive reasoning, and how do we gather information that supports our generalizations that we have. All right, so let's talk about ESP for a moment. ESP, extrasensory perception, is a way that we can communicate without physical means. And there are some basic ways that we can engage in precognition, or excuse me, in ESP. Well, the first one is precognition, where we can predict the future, so something that hasn't happened yet. We can also use telepathy, where we can sense what somebody is thinking across some kind of distance and without any other form of communication. So it's mind to mind. Okay, so it's a way to communicate across a space. And then there's clairvoyance, which is knowing about something that one cannot see or sense. So if I used telepathy, I might sit across from somebody and focus on them and be able to know what they're thinking. But clairvoyance is, let's say I knew what somebody was thinking, but they were in a different building or across the country or across the world. Whatever it is, I would know something that I couldn't see or sense. Okay, so those are kind of different kinds of ESP. You might be thinking, well, ESP, maybe that's a magic trick or something. We'll talk about that because we have to consider this idea called plausibility. Okay, so how reasonable is it that somebody has ESP, for example, that they can know something without seeing it, or they can predict something that hasn't come true, or they can read somebody's mind, for example? All right, these are all things that we have to think about in terms of how likely something is. And what's interesting about plausibility is that it's based on how likely something is to be true based on our observations usually. And what's plausible for one person may not be for another, and there are a variety of reasons why that's true. So plausibility isn't just, is it possible to be true? Is it likely to be true? It's based on your own perception. And there are ways to better objectively understand what's plausible than just to use your own experiences or what somebody else said. Okay. So what happens is that in psychology especially, we use what other sciences suggest will be true. Because psychology is, I'll classify it as a soft science, but it can be made objective. It's difficult to know somebody's motivation, for example, or it's difficult to measure aggression because we don't know what's causing it. Even though there are some operationalized definitions for aggression, somebody might be thinking something different when it comes to aggression or violence or whatever. So it's difficult sometimes to quantify things. So what we do is we use what we know to be true about science, and we try to use scientific methods in order to develop plausibility in terms of being able to generalize something about the world based on some specific examples. Okay. So the question is then, is knowing the future before it happens plausible or implausible? And when we think about that, you might have a knee-jerk reaction like, oh, well, it's not possible to know what's going to happen before it happens. Or you might be thinking, well, maybe it's possible, but only up to a certain extent. So right there, we already know that plausibility is different, and it's contextual, and it's based on what's happening, and it might be based on some kind of observation, and those observations may or may not be independent of some other thing that's happening. So we have to keep that in mind when we think about, can we know what's going to happen in the future? I mean, if I say to you, I'm going to snap my fingers in 5 seconds, 1, 2, 3, 4, 5. Okay, I knew that was going to happen before it happened. Okay, I created that situation, so it's plausible for me to have known the future in that case. Is the sun going to rise tomorrow? Okay, yeah, that's a very strong likelihood. Is it possible that it doesn't? Yes. Is it likely that it doesn't happen? No, it's not likely that the sun won't come up tomorrow. So there are things that have more levels of plausibility than others. And when the things like, is the sun going to come up? Can I predict that I'm going to snap my fingers, right? Do I think I'm going to have pizza for dinner, right? Those are things that are reasonably controllable. People don't really talk about whether it's plausible or not to know that you predicted the future. As a matter of fact, nobody would be surprised if I had pizza tonight, right? Because I have a lot of control over that. But when it comes to other things, we're in less control of, so it's not always as plausible. Okay, so predicting the future in general for things that are outside of our control are generally implausible. Okay, so it's mostly because there is this kind of cause and effect that we may not know. And what's interesting about this, especially when we talk about ESP, there are things that people will try to predict, try to get right. And if they get one thing right that's implausible, then people will make a sweeping generalization that, oh, you can make predictions about other things, so you must have something special about you. Okay, so for things that are subliminal, for example, there are physical events that occur that our nervous systems can perceive that we're not aware of it. Right, so there are subliminal things that happen. Sometimes you might, and we hear this a lot of time with people who are older, is that somebody might be able to know when the barometric pressure is dropping because they're feeling sore in certain joints of their body. And that's because there are medical reasons why that's the case. You have things like arthritis or rheumatoid arthritis that respond differently to pressure differences, and you might have sore hands or something if you have rheumatoid arthritis. So that's a subliminal thing that your body is sensing about the weather. So you might think, oh, I knew it was going to rain tomorrow. Well, you probably did know it was going to rain tomorrow because there was a drop in barometric pressure. You felt it in your hands, and you have unconsciously associated that phenomenon with the fact that it does tend to rain near the time that you experience it. Okay, so there is some kind of causal relationship there. But what happens is that people will often forget about the effect. Okay, they will often forget about the effect and think, oh, well, I knew this was going to happen just because I sensed it, right? I had a sixth sense about it. Well, you forgot about the effect part. Okay, so we have to remember that that the effect came after some kind of cause, and that we can't just ignore the cause because we sensed it, and we can't think of why we may have sensed it. The usual rule of thumb is that if something happened, something caused it. Okay, so how did this guy predict the future, by the way, with the envelope? Well, what happens is that there is a completely reasonable explanation for it. But the problem is that people didn't look for the answer. They didn't look for the physical answer for why he was able to predict the future. So what happens is that people often engage in deception. Trickery, right? That's magic. Long gone are the days when people just generally believe that magic is real. Usually when somebody does a magic trick, there's almost like a tongue-in-cheek thing of saying, if I were a real magician, this is how I would do it, right? This is what it would look like. And that's kind of what happens in this case. So Freed confessed that he was a magician, strongly implied that he used a trick to replace the letter after the event or something else happened. Maybe there was a crony, maybe there was somebody who was a confidant who would... or a confederate, somebody who was in on it, whatever it was, something reasonable happened in order for that prediction to be true. Or he caused the jumbo jet crash, which would be an awful thing just to predict the future like that. I figure I'd use a safer way to predict the future than to create a jumbo jet crash. So he made a confession, and then there was a reasonable conclusion to it. The problem is that the people who covered that event in the news didn't think about the fact that there was a reasonable answer to it, so they just said that it was a miracle, et cetera, and most people believed that just because that's what they were told. So you can kind of see that when we start to make generalizations about what had happened based on a small sample or based on what we know, we start to get into trouble. So I hope you're starting to understand that there are reasonable explanations for why things happen. Sometimes they're outside of our understanding. Sometimes they are outside of our direct knowledge base. But given information, you can figure out what those things are that led to the event happening. So keep that in mind as we go through. So when we feel deceived, we have to do a few things. We have to examine the claims, especially the extraordinary ones. Okay, so for the longest time, crop circles were thought of to be done by aliens, and then somebody comes along and says, well, here, we can replicate these, and they replicated the crop circles using essentially a rope and 2x4s to press down the crops that would make the crop circles. Okay, so people, just because they didn't have an explanation for it, they resorted back to some kind of supernatural phenomena like aliens creating crop circles. So we have to examine those claims, even and especially the extraordinary ones. And you have to look for plausible explanations first before jumping to less plausible conclusions. Sometimes we're limited by our imagination and our experiences in terms of what we think we know about the world. And we assume that if we can't think of the solution, then it must be this miraculous thing. Well, we have to be careful. We have to understand that we don't know everything. I know, a shock, right? And we have to understand that there are things that we don't know, but that doesn't mean that it's implausible. We have to know that there are things that we don't know. That's called the Dunning-Kruger effect. The more you learn about something, the more you know you don't know. But that doesn't mean that there's some kind of extraordinary explanation for it. Okay, and that's why we have to be careful about relying on personal experience, because that does not lead us to the real truth of something. We have to understand that our personal experiences limit what we know about something. The nice thing about plausibility is that we can use it to make initial judgments about how reasonable a claim appears to be, right? So a plausible explanation is useful, but it's not the end of how we start to make a conclusion. So if something is plausible or even possible, that's a good place to start. We need to create create maybe not be the right word. We need to find the resources, and we need to find the evidence that supports the claim so that we can make a conclusion about something. Okay. So what that means is that if we have something that's plausible to happen, but we don't have the knowledge to go along with it, it's not useful. Because what that means is that we're going to go from plausibility to some kind of unreasonable explanation. And we're going to skip the evidence over the middle. We're going to draw an unreasonable conclusion because we lack the knowledge or the information about the situation. Okay, so plausibility can be helpful when you're making an initial claim about something, but you cannot draw some kind of conclusion until you have all the evidence in between the plausible explanation and the true explanation. So an example of that, when you're lacking the knowledge, something that was implausible like space travel is now scientifically plausible. It's happening. Okay. Something like time travel. Wow, that seems like it's impossible, right? That it couldn't even happen, or maybe it's plausible, but only under theoretical conditions. Maybe there's a situation where that happens. Remember, up until like the year 1890 or something like that, the fastest anybody could go was by locomotive, and that had, a limit. And people were like, nobody could ever sustain travel at speeds like that for longer than maybe an hour or so. And now all of a sudden we're going on airplanes that are traveling 500 miles an hour for 4, 5, 6 hours, 12 hours, whatever. And now that's scientifically plausible. And to think of it this way, before locomotives came out back in the 1800s, the fastest anybody could ever go without falling off a cliff was like by horseback. So that would, put a limit on that at, 25, 30 miles an hour. So these things that people thought about being able to do were pretty much implausible. But as we get scientific information, they're becoming more and more possible, and actual in most cases. Right, so we have to be careful about how we use plausibility and recognize that even what we can do now is limited on our current scientific understanding, and we'd be fools to think that we have reached the peak of scientific endeavor and that won't be able to figure out how to travel faster or do things that we couldn't do before. Okay. So if we talk about plausibility and drawing conclusions, when do we use this inductive reasoning? When do we start to induce information, induce theory? Well, what we try to do is we try to use inductive reasoning when we are trying to create an explanation for a phenomenon. Okay. So we use information, we use evidence to evaluate what might be happening to create an explanation. Okay. So we try to use the evidence, we evaluate it, and then we draw our conclusions. Okay. So what's interesting about this whole process is that there is an evaluation that has to happen, and that's probably the most important part of critical thinking, because you're going to be provided with lots of evidence in life, and you have to evaluate it for the quality of the evidence and the quantity of the evidence. So we have to understand that even at this point in our lives, what we know is based on our consumption of information and knowledge. And I'm talking about just like everyday stuff, right? Like what you know about living in a family, what you know about going to the store. That's all based on evidence. What you do, the way that you do life, is based on conclusions that you've drawn about your personal experience, which is a culmination of the evidence of things going around you. I'm thinking of something like going to the grocery store. You go in a certain path. You pick fruits in a certain way based on evidence, based on conclusions. You may have had a certain food that you tried when you were 8 or 9 years old, and you think to yourself, oh, I tried it then, I don't like it, and you won't try it again because you don't like it. Well, we know that people develop different tastes, especially kids have different tastes. And as an adult, you might grow to like something, but you may never try it because you've developed a general conclusion about what you think about something like asparagus, for example. Maybe you love asparagus now, you didn't when you were a kid. Well, if you always just maintain the thought that I don't like asparagus, then you wouldn't give it another try. You would have drawn a conclusion that says, oh, I don't like asparagus, but you actually do. So there are lots of ways to use that in everyday life. Use inductive reasoning everyday life, but you have to keep challenging it. You have to go back and keep checking it, which is a really good analogy for research, by the way, because lots of times people will redo research and be like, well, why are you doing it? We already drew a conclusion, right? But the circumstances may have changed. The context may have changed. What we know about the topic may have changed. The truth of the topic may have changed. Society may have changed, and that changes the response to a topic, especially in psychological research. So we go back and we redo these things. We replicate studies because it's important for us to keep finding small examples to see if we can support or refute some kind of theory that's going on. As always, inductive reasoning has limits, and that's not to say that we shouldn't use it. It's just that things have limits to them. One of the limits of inductive reasoning is that we can't always assume that some kind of inductive reasoning process that we've gone through applies to all cases. So one of the examples that we have here is that William James, who was one of the first psychologists who developed like this kind of like scientific process for exploring psychological phenomenon, wanted to know what color are crows. And, kind of the thought process was that, well, all crows are black. And that's kind of like one of the defining characteristics of crows. And what the suggestion was is that if you took all the examples of crows that you had and created the inductive reasoning that all crows are black, you could be wrong if you could find even one case of a crow that wasn't black. So that's kind of what happened in this case. Let me open this up. Let me shrink this down for you. There we go. So this is the white crow phenomenon, and this is a matter of being able to find crows that have white on them. And what that does is and there's some white crows right there. What that does is it completely flies in the face of the idea that all crows are black, and it kind of supports this idea for inductive reasoning that we have to be careful on the conclusions that we make. We can't say that all crows are black, and what that also suggests is that we ought to be hedging our conclusions and qualifying our conclusions in psychological research, especially in cases where we aren't sure if we can completely confirm some kind of theory that we come up with. And that's kind of the nature of theory anyways, is that it's a collection of ideas that tend around a certain theme. That does not mean that it's a law. There isn't a law that all crows are black. It's a usual scenario, and if you wanted to use an inductive process, you could say, well, we've observed 1,000 crows and one of them are white, so our conclusion can be that crows are generally white unless there is some kind of genetic anomaly or whatever it is. So you can say that kind of thing. So the conclusions that you draw that are inductive need to be in the context of your observations to say that, among 10,000 crows in Europe, let's say, all but 4 of them were completely black. And then your conclusion would be that, 99.996 crows are black. And that would be a fine thing to say based on your inductive reasoning, but to make a sweeping generalization to say all crows are black would be inappropriate. So, within the context of research, we kind of know that. But in everyday life, we don't do that. We just make sweeping generalizations like, hey, I went to McDonald's and the food was bad, so I don't like McDonald's. Oh, you don't? What if you went to a different McDonald's and, or maybe that one McDonald's was really bad and the other ones are just fine, but you'd happen to pick a bad one or whatever. We tend to make these inductive reasoning sweeping generalizations, and we ought not to. Okay. So again, we acknowledge limits of induction through that example with the crows. We can't be certain all crows are black through inductive reasoning. We cannot prove it either because we can't find all crows and sample them. That's just implausible. It's possible, but it's implausible. But we can still generalize that most crows are black. You could generalize that you generally don't like McDonald's if you've tried, 25 or 30 of them, and some of them were okay, but generally they're not good. So you can say, generally, I don't like McDonald's. So we need to be hedging our observations. Otherwise, we find ourselves making inappropriate conclusions. Okay. So when we do make an inductive conclusion, again, we need to make sure that we say that our conclusion is not definitive because we have only a limited amount of observations that we made, but we have, high quality evidence that we have looked at. For example, I've been to 50 McDonald's. I've only liked a couple of them. So, based on my evidence of sampling 50 McDonald's, I feel like I really just don't like McDonald's. Okay, fine. That's qualifying. That is making sure that you are saying that under these conditions, I don't like McDonald's. Just like the crows. Based on observing so many crows, we've only found a couple that have any white on them. So generally, based on our findings, crows are black. Okay. So when we think about all those qualities, we can kind of come down a checklist of things that make a strong inductive conclusion. So it's highest quality evidence, and not refuted by any other high-quality evidence. So let's say in the example of the crows that we find a whole community of crows in Russia that are completely white. It's like, oh, that's high-quality evidence. They have found them. They have done an ornithological study and have shown that this is indeed a flock of white crows. So all of a sudden we have refuted evidence from a high-quality evidence source, presuming they do good research. So unless we have something like that, we can say that we have high-quality evidence. And high-quality evidence is a very it's an in-depth term, and in a class like Research Methods and Design, we'll talk about what qualifies as high-quality evidence in more detail. But generally, it requires a lot of research. It requires you to go through a methodical way of parsing out the information, of identifying whatever it is you're trying to make a conclusion about. It's way more in depth than what I just said in 3 sentences, but that's kind of a taste of what it takes. Okay. You will also evaluate the quality of evidence on 2 or more sides to evaluate it. So you would be going and looking at if in the case of the crows, you would go look at crows in different parts of the world to see if there are other cases. So you would do your due diligence to go out and try to find counter evidence. And then you have to think about which evidence that supports my conclusion is better, and then you have to kind of review and evaluate the evidence to see if it's good quality evidence or not. So that brings us to kind of standards of evidence, where the standards of evidence are used in how we decide whether or not evidence is good or if evidence is bad. And again, when we get into a class like Research Methods, there will be a lot more that goes into that than just what we're saying here. But we need to make sure that scientific research is used when we're trying to create a good conclusion, and we want to do that as opposed to non-scientific evidence. I've had people that have said, hey, I read this online. Okay, well, great. Where'd you read it online? Well, I read it, on like Psychology Today, which is kind of a magazine based on psychological science. And I say, well, yes, that's fine, but it's not as regulated. It's not peer reviewed. It's really just, edited by some kind of editor. And anybody who wants to write an article can really do it as long as it appears to look good. But if they say to me, well, I read it from the Psychology, or from the Journal of General Psychology. I'm like, okay, that's good because that's a peer-reviewed journal. They are written by people with high credentials. They're generally reviewed by people not only in the field as part of the peer review process, but also people who are experts in the content area that the person is writing in. So we have good scientific research that comes from good scientific sources, but we also have people who are just like Googling stuff and looking at .com websites and kind of these trade magazines. And those publishing means have much different and less formal rules for how they publish. People also use what they hear on TV and stuff, which is not a great way because people can get on TV and say anything they want to. Even the news can't be trusted. I'm not anti-news. It's just that it's not a very scientific way. It's really like 3 steps removed from the actual evidence that's being talked about by the time it gets to the news. Okay. So here are some non-scientific approaches to evidence and some ideas behind that. When we think about ways that we know something or the ways that we develop evidence, we have to be careful to stay away from our own subjective experiences as the sole or primary way of understanding something. These things are not bad ways to start ideas and to have jumping points for getting into rummaging through information. But personal experience, anecdotes, common sense belief, authority, informal observations, those are non-scientific sources of evidence. Now, you can take those, as I said, and develop evidence based on that by doing some research. Those are good places to have ideas. But generally, those are not where we end our exploration of evidence. Okay. Mostly because those are not based on that systematic scientific method. They're not objective. They're considered to be weak support because they lack that scientific method in order to gain the understanding. Again, they lack quality and quantity of observation generally, which is a sad thing because people like to think that things like common sense belief and their own personal experiences are valid ways of consuming information. They just are not a great place to finish the exploration. So we're going to be looking at 4 of these very carefully. So personal experience, anecdotes, common sense belief, and statements on authority. Those are kind of the 4 big ones. And we'll talk about some other ancillary things in the meantime, but those are the 4 main perspectives on non-scientific sources that we're going to look at. Okay. So with personal experience, it's basically something that you've experienced that you consider to be more or less truthful. It's evidence, something that you know to be true. These are sometimes testimonials or introspective self-reports, which is kind of something that goes back to the early days of psychology, where introspection was the way that people that they explained internal processes, but you can just call them self-reports, that's fine. And they take those as evidence, and that means that we assign too much truth to what we experience, that we draw conclusions too readily based on what we think to be true, based on what has happened in our lives. These are sometimes feelings, experiencing, that somebody is aware of at the time. Lots of times we call this a gut feeling sometimes it's intuition, and that can be problematic because our intuition, while can keep us safe in certain situations or as maybe a heuristic or a shortcut to knowing something, is not a great way to develop a generalization about the world. Okay. The reason why people use personal experience as evidence and believe other people's personal experience is because it's oftentimes what we call compelling and vivid, meaning that people believe it because you can paint a good picture, especially a storyteller. So sometimes we feel like if someone tells us this story about what happened to them, then we believe them because not only is it interesting, but they believe it themselves. They've created all this detail, and they've painted this picture of what's happening, and we tend to believe them based on that. So we have to be careful that we don't just accept personal experience because someone tells it to us. Okay. The weaknesses of personal experience is that it's oftentimes subjective. I mean, always subjective, I guess, right? Because if it's a personal experience, you're reporting what happened to you and it's subjective. Oftentimes it's biased. People want to tell a story. Usually there's a purpose for the story. And if it's personal experience, they will skew some things that kind of steer you toward a conclusion they're trying to come up with or something they're trying to tell you. And there are other perceptual and cognitive errors, like sometimes you don't remember things the right way. Sometimes you didn't perceive something the right way. And you will not question that. You will generally just accept your own perceptions, and your cognitive errors start to take over, and you report things that are inaccurate. What happens too is that people are oftentimes not conscious of the reasons why they are sharing something, or conscious of the reasons why they are misinterpreting something. So these unconscious reasons can skew the way that you report behavior and experiences. If you tell a story and you suspect why somebody did something, well, you really don't know. You can make an assumption, again, which is not a great idea, about their motivation, but you really don't know why somebody did something. So if someone bumps into you and you say, this really mean person bumped into me, and so you say, oh, that's a bummer, why would they do that? And all of a sudden you've kind of painted this picture that somebody is just mean, they bumped into you, and they're a jerk for it. But maybe it's because 10 minutes earlier you saw him in the store and you kind of sneered at him, but really what you were doing was sniffling because you have a cold. So maybe there's some kind of misunderstanding that goes on there. So the personal experience can be based on something that you're not even aware of, and the circumstance surrounding it is not based on what you thought it was, or somebody's motivation was questionable or whatever. So you have to be aware that this personal experience is oftentimes the result of faulty completion of information that wasn't completely available to you. When we think of this idea of personal experience and the fact that we don't always perceive things in an appropriate way, we can look at the Mueller-Lyer illusion, and this is an illusion where these two line segments between A and B are the same size, but because there is a reference frame for these two lines, where these kind of brackets looks like you point in, then the other ones looks like they point out, we tend to think of them as separate lengths, even though they are the exact same length. So this is a perceptual illusion. And what happens is that if I asked you, which one of these is longer, without seeing this ruler and kind of knowing what we're talking about, you would probably judge line segment AB to be longer than BC, and you'd be very sure of it. The problem is that they are the same length, but you would believe that that's not true. Clearly, that creates a problem with how we report reality, because you would die on the hill that one of these lines is longer than the other, even though they're not. And your truth, the thing that you would be arguing, would be incorrect. And I don't know about you, I don't like being wrong. It's okay to be wrong. I know that consciously, but nobody really enjoys to be wrong. So you would be wrong about it, and what's worse is that you may not even know it. You may, think ill of somebody else because of their perspective, whatever it is. You would be wrong in it because of this perceptual illusion. So we have to be aware of the fact that there are times where we might not perceive things in a true, real way. I know, right? It's mind-blowing. So one of the things that leads us into thinking about the world in a way that we believe to be true is this thing called naive realism. Naive realism, in a nutshell, is that I believe that the way that I see the world is the way that the world really is. Okay, that's a very difficult thing for people to wrap their head around, to think that the world is not like they think it is. All right, naive realism is thinking that the world, the reality of the situation, the status of things is exactly how I see it. That's not the case at all. Now, generally there's shared reality, right? People kind of understand that we all can agree on what a tree looks like, or what the color green is, or that today is, what is today? Thursday, I guess. That today is Thursday. We can all agree on those things, but there are lots of things that we don't agree on. But we don't ever talk about that, really. We just assume that other people see things the way that we see things. Okay? And that's kind of problematic to think that the way that we perceive things is the real trustworthy way, even though we are susceptible to flaws. So we have to be careful of naive realism in how we consume information, and recognizing that we might not see things the way that somebody else does. And that doesn't mean that one of us is wrong necessarily. Sometimes it is perceptual. Sometimes we see things a different way. But sometimes we see things a different way, and it's the wrong way. Ugh, yikes, right? Now, another way that we can engage in non-scientific ways of gathering evidence is through anecdotes. An anecdote is kind of related to personal experience, but an anecdote is more of a story. And if there's something that we know about stories, is that they change over time. Think about the fish that you caught, right? And what's interesting about memory is that we usually tell stories, and it's not based on the original event. It's based on the last time we told the story, which is why those fish get bigger every time you talk about them. So, you put your hands up and you caught a fish, yay big, let's say your hand or a foot apart or whatever. And then the next time you tell the story, the fish is going to get bigger because you're not basing your estimate of how big the fish was off of off of the first story, it's off of the last story. And we tend to exaggerate. So every time you tell a story, it gets more fantastical. Things that get exaggerated, and then all of a sudden we have this story that might be true, but maybe has some embellishments to it. We can also have anecdotes about other people and what they say. So we can not only tell our own stories and create these anecdotes about them, but we can also tell stories about other people, and you can only imagine how much those anecdotes exaggerate. Okay, so the strengths of anecdote are kind of along the same lines as some of the ways that we use personal experience. So we have these vivid illustrations. We can tell stories about things, about people, about situations, and we can use a real world example to do that. So we can make something more real than talking about a specific example. So we can generalize things using anecdotes. Okay, a weakness is that, again, they're not based on this systematic scientific observation, and they're also unique, which means that you can't repeat them. People don't oftentimes have similar odd stories to tell. And so the anecdote may not generalize to other people. Okay? Which means that the anecdote overall is an okay way of telling a story about reporting something, but not about the truth of it without careful systematic observation that follows it. Now, another closely related non-scientific source of evidence is through common sense belief. And common sense belief is just kind of like these rules of thumb, these theories that come to be true or that we assume to be true. You'll usually know that you're hearing something that's common sense belief by hey, you know what they say, or everybody knows that, or have you heard that? And all these things that we assume to be true. Things like an apple a day keeps a doctor away. It's kind of a cute saying, but it's really not that authoritative, right? Probably the Apple lobby came up with that so people would buy more apples. I don't know. Usually what happens with common sense belief is that it's a consensus, meaning that more people than not believe the view that you're using. And when people tend to believe things all at once and without refuting it, it tends to be called this thing called groupthink. And what happens with groupthink is that people tend to believe a certain way, everybody agrees on it, and nobody ever questions the belief. So the common sense belief can be problematic. Usually common sense belief is full of people who are assuming things about the world. So if somebody says guys are just more aggressive than girls. Okay, that's a common sense belief. Well, there's a little bit of reason to support that, where we talk about hormone development, testosterone, and things like that. But women are every bit as aggressive as men. It just looks different, right? We can talk about aggression in different ways. Lots of times people think about physical aggression. That can also be verbal aggression. It can be emotional aggression. Really, anything that you do that's designed to try to harm somebody can be classified as aggression. So when you classify aggression and the more appropriate broad term rather than hitting and punching and things like that, you can see aggression coming out lots of different ways. But you know what they say, men are more aggressive, right? So these common sense beliefs become problematic, and we ought to call them out as common sense beliefs. All right, so the weaknesses of common sense belief are if you can guess. They're not based on careful, systematic scientific observations, and they're biased based on these cultural influences. So depending on the culture that you have, there are some common sense beliefs that you believe in. So you can ask people who have different cultural backgrounds than you to talk about some of the things that they just think are true, and you'll get a lot of very interesting and varied results. And statements of authority are another problematic way to rely on information. And what's interesting about statements on authority is that, isn't that what we do already? Like if we're looking at research, aren't we relying on the statements of authority? The answer is yes, but. Yes, the people who write these articles are generally authoritative, but these are people that also go through a lot of rigorous processes to get their things published that are overseen by other people who are doing a good job of gatekeeping inappropriate information. Okay, so in general, statements of authority are made by people who we claim to be an authority. Lots of times we use celebrities as authoritative figures, and that's not a great way to get information or to learn about the truth of something. Usually what happens is that people will use statements of authority from celebrities to support everyday evidence. I think one of the more problematic ways that people use statements of authority from celebrities are through Gwyneth Paltrow's company Goop, that has all kinds of healthcare products that are mostly hokum, not a lot of science that backs it up, and they're very sensationalized, and because she does them, other people do them. So we have to be careful that just because someone's in an authoritative position doesn't mean that we automatically believe what they think. Celebrities are an example. There are some people in positions, even at a college or university where they're in a position of authority, they say something and we believe them. Well, we ought to be critical consumers of what they're saying. We need to check it against what we know to be true, to check it against the evidence that we understand. Sometimes people just give information that's helpful to know, but other times we have to be a critical consumer of the information that people are trying to provide to us. So some of the strengths of the statement of authority are that when somebody actually has expertise in a content area, then they can be believed. Usually when people are authoritative and they have expertise in a content area, if they've done good research and they're reporting findings of research. People who give TED Talks generally do a pretty good job of that, where they have evidence that supports what they're saying. So these people are typically authoritative on the content that they're talking about, and that can be good. People who are in positions of authority and who understand a topic well are convenient sources of information, because if you were to gain your own expertise, and it would take you a lot of time. So we can use people who have authority in a topic, as long as you evaluate it and judge it to be good authority. Okay. Sometimes, though, people in positions of authority can give false statements, or they can be misleading, or they can not give enough information to have a comprehensive understanding of the topic, because they're usually summarizing. Sometimes people in authority can be biased. Lots of times that happens on news, usually political-based situations where people will spin information in a way that is not appropriate or isn't contextual or whatever. So do be aware that statements of authority can be good and bad. Okay. So non-scientific sources of evidence, this is a breakdown of the approaches that we just talked about with their strengths and weaknesses. Again, this is taken from your textbook, so you can find that in your textbook. I believe that to be table 3.1. Just briefly, I want to talk about literature reviews, because literature reviews are ways that we can get information. And really what a literature review is a combination of different resources about a particular topic, and with the goal of looking at the quality and the quantity of the evidence provided. So lots of times with literature reviews, we'll try to do what's called an exhaustive lit review, which means that we will look at as many references and resources as we possibly can before we run out of things, or before the references start to say the same things over and over again. You can create a good inductive argument by using evidence gained by a literature review, where you're looking at lots of different resources and then finding out what the general trends of those resources are. Pardon that this slide is very wordy, but I wanted to put all these points on one slide. These are from the textbook, so you can refer back to that as well. The the nature of literature reviews are that you have these statements that are kind of very small snippets of the research that is cited in each of them that supports a central idea. So this idea is generally, can critical thinking be taught? Can you learn it, or do you just born with it, right? So this is just a snippet of literature that the authors of the textbook have aggregated, and you can see that there are different levels of information here that cover theme issues, that cover learning dispositions, some that actually contradict the notion of learning critical thinking, and overall you would come up with a conclusion based on balancing and evaluating these statements. A full lit review is rather lengthy. I'm seeing about 25 or 30 references altogether on that slide. So you could expect this lit review to be about 20 to 25 pages, I would assume, based on what I'm seeing here. This is just an abbreviated version of it. And when you look at these statements, again, you can cluster them in kinds of themes and what they're talking about, and then you would come up with a general conclusion based on it. And by the way, generally, the conclusion is that yes, you can be taught critical thinking, but there's also a but what statement that goes along with it. That kind of leads us into analyzing and evaluating that inductive argument. All right, so the overall task then, based on collecting information, just like we saw in the lit review, is first to identify and understand the claim or question. So for example, can critical thinking be taught? Can we learn it? Okay. 2, we would gather, compare, and evaluate all the evidence, which is exactly what we did during that lit review. And then the last thing is that we draw a well-reasoned conclusion, and we want to take into account the quality and the quantity of the evidence provided. Okay. So once we have those 3 steps in mind, then we have to draw that strong inductive conclusion. Okay. So when we talk about inductive conclusion, there are some aspects that we have to keep in mind. So when we look at that lit review, we think, oh, can critical thinking be learned? You might think to yourself, well, gee, we want to find all the evidence that says yes, that it can. Well, maybe, but if you did that, then you would be ignoring a critical part of critical thinking, and that's looking at the counter evidence. So if we look at 5, 6, 7, 8, okay, you can see that these do not necessarily support the idea of learning critical thinking, which is fine. That's okay. Can we still conclude that instruction improves critical thinking? Well, when we look at that lit review, we see that most of the high quality research does support that conclusion. Okay. However, there is a degree of uncertainty to it because not all the evidence supports it. And again, if all the evidence supports one side of an argument, we call that a cogent conclusion, meaning that all evidence supports it. In reality, especially in psychology and social sciences, that's not the case. Not all the bits of evidence are cogent. Okay. Okay. So what happens is that if we were to make this a deductive argument, right, we would be led to a false conclusion. Remember that if we started with an overall statement that yes, we can learn, but there could be a problem, then if we tried to find all the little bits of evidence, we'd be going the wrong way because we would be missing out on some of the critical evidence. But if we start with evidence and then try to support a conclusion and draw a generalization, we'd be doing a good job. When we talk about that degree of uncertainty, what we're really talking about is what we call a tentative conclusion. Okay, we call that hedging or creating a qualified conclusion, meaning that we accept a conclusion but with some kind of qualification. Like instruction can improve students' critical thinking is a tentative conclusion, okay, because we understand that there are some limitations to it. Okay, there are some ways that it cannot, or that we haven't found that it improves thinking. For example, instruction can improve critical thinking, but not critical thinking in certain areas maybe. It's only inside of the bounds of the research that we've looked at. Okay. So we draw that conclusion based on the evidence for now. And what that means is that there might be situations where there is other evidence that will emerge that contradicts ours. And that's okay. That's what's nice about science, is that we're always looking to challenge ideas. Now, the strength of our conclusions are varied, and it's based on the amount and the kind of information that we are assessing. So the strength of our conclusion does depend on how much good evidence supports it and how little counter evidence there is available to it. Okay. So we can come up with this conclusion that instruction improves students' critical thinking, and it's a fairly strong conclusion because even among the evidence that does not fully support it, there are still glimpses within that evidence itself that it is supporting it somewhat, just not as strong as some others might. So when we talk about quantity and quality of evidence, we're talking about how much evidence there is. So that's the number of studies and the size of the samples in each study. So essentially the number of people that contribute to the data. Okay. Then there's the quality. Is it scientific evidence or is it non-scientific evidence? Or how were the studies done? Were they done well? Were they done were they done with some inappropriate statistical measures? Were there questions that could have been asked a different way? So you actually have to know about research in order to answer that question. Was it done well or was it not done well? Okay. And then once you've kind of weighed the quality and quantity of evidence, you come up with a conclusion, then you can start to generalize and you can say, okay, based on the evidence that I have found, I can now come up with an idea or some kind of conclusive theory about what we're seeing here. So once you can generalize your findings to a larger population or other settings, then you can start to create a theory that kind of identifies your overall themes and your overall ideas. So the theory is supported by that high quality evidence and it's better justified. And what else happens is that if you are able to use a theory and create an explanation using that theory for what you're observing, and other new bits of evidence do support that, then that strengthens your theory as well. Here we're looking at science versus non-science. We're going to kind of skip over this because we've talked about this in other ways. So we'll go on to the thinking errors that are related to generalization. There are several thinking errors altogether. We'll take a look at 4 of them. But we have this first one called hasty generalization, meaning that as soon as we find evidence that supports a conclusion that we like, we make that conclusion. That's not good. So if you make a generalization too soon before you've looked at all sides of an idea, then you've made a hasty generalization. Okay. We can also make what are called sweeping generalizations, and I've said this a couple times. And a sweeping generalization is when you overgeneralize. So you say something like, oh, well, I don't like McDonald's because, they made a burger I don't like, so I'm not going to eat McDonald's anymore. And my conclusion is that I just don't really like fast food because I don't like McDonald's and McDonald's is fast food. So that sweeping generalization is making a conclusion about other fast food restaurants based on the observation you have of the one type that you were quote unquote using as evidence. Again, this is just an everyday example. It's not scientific, but it's accessible. So if you make a sweeping generalization, it's because you have made a generalization about things that are outside of the scope of what you were considering as evidence. We can also have what's called a red herring fallacy, meaning that sometimes we get caught up in an argument that is not part of what you're researching. And that can be really tricky for new researchers too, because everybody wants to kind of go out and answer all the world's questions all at once. The problem is that we need to focus on something. And what ends up happening is that people start to follow all these different arguments and all these different bits of evidence trying to answer the world's questions. So the red herring fallacy is when you're deliberately sidetracking an argument using some kind of irrelevant reason. All right, so here's an example that comes from the early 2000s. Senator Snide, why did you continue to support the Iraq War when it was discovered that Iraq had no weapons of mass destruction? Then the senator retorts, I've always been a patriot and a staunch supporter of our country. It's like, okay, fine. What does that have to do with the question that was being asked? Usually when people sidetrack you from a question, it's a red herring. And that's usually an attempt to divert your attention from what they're asking you, and usually to paint themselves in a much better picture. Okay, so here's another summary that you can look at, take a screenshot, but it's also in your textbook. This is table 3.3 from your textbook. This is a rundown of the thinking errors that are related to relating to making generalizations. All right, so that is it for chapter 3. Take a look at any slides that you need to go back over, ask any questions that you have. Read the text if you have questions, that's fine too. If you'd like more examples of some of these, the internet can be your friend. You can Google some examples. That won't hurt my feelings. Just as always, be a good consumer of research and don't just don't believe everything you read. Make sure that it's relevant to our textbook and everything. All right, we will pick this up again in chapter 4.